So in our video we'll be going over the egg drop test. The objective of the test is to build a structure around an egg so that it doesn't break. The structure that we'll be building will be made out of everyday materials. So the structure will be basically made so that it doesn't break and it lands safely on the ground. So when the egg is up high, it has potential energy. Potential energy is a function of height. Mass times gravity times height. So the higher you go, the more potential energy you'll have. And as soon as the egg is dropped, that potential energy is then converted into kinetic energy. So the structure is supposed to redirect, absorb, or reduce this kinetic energy so that the egg can land safely on the ground.
Each one of us is going to have two structures with one egg each, and it's going to have a 2-meter drop. So basically we're going to do a system where the most points win, and the lighter structure gets a better score regarding to weight. The first one gets 25 points, the second one 20, and the third one 15. The other criteria is that if it breaks or it doesn't break. So if it breaks, we'll get no points, and if it doesn't break, you'll get 25 points.
It cracked. Good the last time. One, two.
Oh my.
The egg lives. Oh. It's good.
I told you. Some of the key concepts we picked up and tried to incorporate in our experiment are about momentum, pressure, air resistance, angular momentum, which is the object's tendency to continue spinning, and finally gravity. When designing the structures, we looked at combining the effect of power, gravity, motion, and inertia, which were probably sufficient enough to result in an impact between the egg and the structure. The reason why the balloon structure with popcorns in it saved the egg was because it reduced secondary impact, which is the impact between the egg itself and the structure. This is why when you consider the larger picture of this design, scientists primarily try to build structures that reduce secondary impact by incorporating airbags, padded dashboards, collapsing steering wheels, and even seat belts. The other reason why the balloon structure also survived is because of air resistance. Air resistance diminished the net force acting on the object and was able to land with a net force almost equal to 0. The other reason why MARLON's structure survived was because of the parachute effect. This effect reduced the velocity as the egg and in its structure was touching the ground. Therefore, the force on that structure and therefore on the egg was much less than if it did not have the parachute effect acting on it. Overall, we can conclude that the egg drop test was fairly successful, and we were able to learn the effects of layering our structures, effects of secondary impact and primary impact on our egg, and were successful in creating good structures. And we also learned from the structures that failed about the forces that act on the egg. Thank you.